All right, guys, so we're going to go on and get started with the lesson today, but before we do, thank you. Yep. For 27, 28, and 31, so name the parent function and then describe its transformation. So before we get started, we're going to do homework questions. So it was from 1.1 problem 21. So again, I'll go over 2 to 3 homework questions if you have them. If not, we'll just go straight into the lesson. So we'll look at this one here. Now, problem number 21 gave us this interval, and it wanted us to write it in set builder notation. Now, set builder notation is our braces listing the set based off the description given. Now, we normally start brace X and then describe the type of numbers. Now, since it is an interval, we're talking about the real number system. So some of the homework I've seen so far have given me brace X as an element of the real numbers, but we don't need it. It's not wrong, but we just don't need it. We can say brace X bar, because brace X bar is the set of all real numbers X such that. So it is telling us it's the real numbers. The only time we have to put something different in there is if we're talking about the integers, the whole numbers, the natural numbers. We're talking about a group other than the real number system. Now the description is going to be our interval here. We have to change it from an interval to an inequality. Now since we're given one interval and it is bounded, because we're going all the numbers from -5 to 16. -5 is included, 16 is not, and we want the numbers in the middle. So for inequalities, we will have an X, because we're saying that the numbers are between these, or X, or whatever that value of X is going to be described as bigger, less than, between the number groups. Now, since we're shading in the middle, X for this inequality is going to be in the middle, because we're saying that X is going to be bigger than -5. -5 is less than X. So how do we tell it's bigger than -5? So here we're saying, and it's like it's going to be between -5 and 16, because it's bounded, because we're given the 2 bounds of the interval. The only time we won't have kind of a bound is when we're talking about, say, -5 to infinity. So then we're just saying X is bigger than -5, greater than -5. So here, the 2 endpoints that we have are -5 and 16, and X is in the middle. So for inequalities, we'd put it in the middle. Now, because there is a brace with -5, or bracket with -5, we'd say less than or equal to. -5 is less than or equal to 16. Or sorry, -5 is less than or equal to X is less than 16. So -5, less than or equal to X, less than 16. Any other questions for the homework? Yes, sir. Yeah. So this would be, so that one's 1-2. This is 1-1. This was from last week. Any questions from last night's homework? 1-2. You good with 1-2? Yeah, this is 1-1. Yeah. Yep. So this is 1.1. No. So this is 1.1 from last week. I will name all the section, the homeworks, by the section name it is. So 1-1. So last week we did 1.1. Yesterday and Tuesday we did 1.2. So the homework title will be 1.2. Okay. What we're looking at today, and what we're talking about today is transformations. We're continuing talking about transformations, moving a function up, down, left, right, stretch, shrink, reflections. But unlike yesterday, we're not just describing it, we're going to be applying it. You can put it on my desk. We're actually going to be applying the transformations to a given function. Now, when we apply these transformations, we have set ways, notation, function notation, to be able to apply it. And it's going to be very helpful for y'all to stick to or kind of see the notation that we use. Because there is a decent bit with it and not a decent bit with it. There's a lot, not a lot, all at the same time. Because when we talk about a horizontal translation, we talked about this yesterday, it's moving the function up or down. We're affecting the y values. We're increasing, we're moving all the y values up of the original function. They're going to be a higher value by a certain amount. Because if we move the function up 2, it means every y value is increased 2 by 2. So if the y value was 4, it's now 6. If it was 8, it's now 10. We move them all up. And when we do this, and especially to the function, we do have a specific notation or specific way we can do this. Because that's our vertical translation, we're moving it up. So, you don't have to write all this out. I think you have it already. I already have it filled in. The graph y equals f of x plus k is a vertical translation, and we can use this f of x plus k to help us apply a vertical translation, moving it up or down. Because we will replace k with the amount that we're moving it up or down. If we're moving it up 4, it's going to be f of x plus 4. If we're moving it down 2, we'd really say f of x plus negative 2, or we can just say f of x minus 2. Plus a negative, minus a negative are the same thing. Horizontal translation. We use the notation f of x minus h, where h is the amount that we move it left or right. Left is going to be a negative amount, right is going to be a positive amount. And it's that value of h what we're going to plug in. And our horizontal translation is affecting the x values, our input values. So we're replacing what's inside the function with that. Okay. Now I feel like for the most part, us seeing and talking about the definition goes so far, I think it's better to actually apply it and see how these work. Now for these first few here, we're going to talk about the function f of x equals 2x plus 1. We're looking at f of x equals 2x plus 1, and we want to apply these transformations to it. So we want to write a function g. So we're saying g of x. G of x, f of x, h of x, q of x, these really don't matter. It's just telling us and helping us specify the different functions from each other. Because if we called them all f of x, it would be hard to tell which function we're talking about. Because if I was here or you were here, we could point at them and say which f of x we're talking about. But it's nice to have different lettering so I can easily specify and talk about two different functions at the same time, and we know which one is which. Now for us here, we want to write a function g whose graph is a translation 3 units down of the graph of f. So what we're talking about here is a vertical translation. And how we talk about a vertical translation is the function we're applying it to, so f of x in this case, plus k. K is our amount we're moving it up or down. F of x in this case is the function we're applying it to. K is going to be our amount that we're going to move it. So the first thing we're going to look at is k. So we're not going to mess with f of x yet. But our k is our movement up or down. How far are we moving this graph up or down? 3 units. And we're moving it 3 units up or 3 units down? Down. Now as a number, we consider down to be negative. So we can say that we're taking f of x, our function we're applying this to, and adding negative 3 to it. We don't normally talk about it as plus a negative. We just say what? We're really just saying that we have f of x, what, minus 3. We don't say plus negative 3. We do, but it's really just the same as saying f of x minus 3. Questions on what we've done so far? Okay. Now we need to find our new function, because this is helping us be able to apply it to it. So we have g of x. So f of x, we still have f of x here. We haven't put anything into these parentheses. We haven't changed what x is. It's still just f of x. Now they told us f of x is equal to what? 2x plus 1. So we're going to replace f of x with its function. So we're replacing this f of x with 2x plus 1. And when we replace something or plug something in, we always put parentheses around it, just in case we have distributive properties or negative subtraction. We have anything that's going to affect the signs itself. Questions on what we've done so far? Because so far we've done what? Plugged in our transformation for k, the movement up or down, which was -3 because we were going down 3. Then we replace f of x with what it's equal to. So now we have parentheses 2x plus 1, close parentheses -3. Questions on this so far? The last thing we need to do is we need to simplify it. I'm going to move it up here just to give myself a little more room. So those parentheses are around the 2x plus 1. Is there anything in front of the parentheses? Is there a number, a sign, any term in front of that parentheses? No. So what we can do is we can drop those parentheses. As we multiply through by 1, there's nothing being applied to it. So our 2x plus 1 is just going to say 2x plus 1. We don't need the parentheses anymore. And we still have the -3. Now at this point here, we can say we're done as long as there's nothing we need to simplify. There are no like terms we can combine. Are there any like terms we can combine here? Well, yes, the 1 minus 3, yes? And 1 minus 3 is -2. So it tells us our new function, g of x, is equal to 2x minus 2. Question? Question? Any questions on how we got 2x minus 2? We good with this here? Now, what this is telling us is that this function here, when we went from 2x plus 1 to 2x minus 2, we moved the whole function down 3. (2x plus 1, 2x minus 2). Going from the blue graph to the red graph, it did indeed move everything down 3. That's it. Questions on this here? Let's look at the next one. We want to write a function h, whose graph is a translation 2 units to the left of f. So we want to write a function h of x, whose graph is a translation 2 units left of the function f of x. Now, you don't have to rewrite this. I'm rewriting it here, so I'm not having to scroll up and down. We can see everything on the same page. Luckily for y'all, it's all right there on the same page, so you don't need to rewrite it. It's a little bit easier to see. Now, for us here, we're talking about a translation to the left or right. That's our horizontal translation. In the general form, for us applying a horizontal translation, we have it written as f of x minus h. The f is there just as a standard letter, but we're applying this to a function f, so we would say f of x minus h. If we were applying it to the function g, it would be g of x minus h, where h is the amount we're moving it to the left or to the right. Now, how far are we moving it to the left or to the right? We're moving it 2. We're moving it 2 units to the left, yes? So it is still negative. Because again, we said left and right's always the opposite of what we think, yes? Because x plus 2, as we saw inside the parentheses or absolute values the last few days, is going to the left, right? And if it's x minus, it's going to the right, yes? So let's just say I didn't put that extra minus. We had x minus 2. X minus 2 in parentheses would be 2 units to the right, because it's the opposite of what we see. There's one way to look at it. Also, we're talking about the value of h. H is moving 2 units to the left. Left is still negative. And as we plug that negative in, we have x minus negative 2. Do we leave minuses and negatives next to each other? No, we don't normally just say x minus negative 2. We just say that it's x plus 2 because of those negative and negative. When we subtract a negative, the negative and negative becomes a positive. Again, that opposite of what we think. Left, we now have the x plus 2. Questions on this here? Questions on anything we've done so far? Because 2 units to the left, yes. So left would be negative 2. So now negative, negative, because we have x minus negative 2. We don't leave it as minus negative, because 2 negatives make a, so it is x plus 2. X minus negative 2 is the same as x plus 2. Does that make sense? Questions on anything we've done so far? So if it was 2 units to the right, so right is positive, yes? So we would just have x minus 2. We don't have the negative negative if it's x minus 2, so it would just stay x minus 2. Because when we plug it in, we plug in that value of h. We do consider left to be negative, right to be positive for the value of the movement. Here, the value of the movement, left 2, is negative 2. If it had been right 2, the value of the movement, that value of h would be positive 2. Does that make sense? And then after we plug it in, we get this x minus negative 2. We don't leave it as minus negative 2. Because negative and negative gives us the plus. We ready for the next step? We need to plug this into our function. Now, at this point here, do we have f of x anymore? No, we have what? F of x plus 2. We've replaced this x here with what? X plus 2, which means every x on the other side of that equal sign also has to be replaced with x plus 2. All the other numbers are going to stay the same. So we have 2, because the 2 will still be there. But here we have what? Our x, yes? And we replaced it with what? X plus 2. In the original function f of x, we had 2x. Now we have 2 times our x plus 2. We replace that x with x plus 2. Everything else is going to stay the same, because the rest of the function was plus 1. So we took every x, because here we have x plus 2 for f of x. We replace this x with x plus 2, which means every x on the other side has to be replaced with x plus 2. No matter how many times it shows up, we're replacing each one with x plus 2. Questions on this here? Now we just need to simplify. We need to get rid of parentheses and get our like terms together. Now this time we do have a number in front of the parentheses. Yes? So we will multiply through. So our 2 times x is 2x. 2 times 2 is plus 4 plus 1. Now we do have like terms. Our 4 plus 1 gives us, telling us that our new function, the function that moved everything 2 units to the left, is going to be 2x plus 5. Questions on this here? Here? So this is getting there. If I said we had f of 3, how would I do that? How would we calculate this? We'd say what? Because we replaced x with what? 3. So we'd have 2. Would I still have x anymore? We'd have 3, yes? Because this should be familiar. You should have done this, I think, in Algebra 1 function notation. So 2 times 3 is 6. 6 plus 1 is 7. So it tells us f of 3, when x is 3, the value is 7, yes? If we said f of 4, we'd have 2 times 4 plus 1, yes? Well, 2 times 4 is 8. 8 plus 1 is 9. So f of 4 is, we kind of remember doing this, yes? Let's do one more. Let's say f of circle. No, let's not do circle. Square. What did I do? I replaced this x with a square. So that means I still have 2 times square plus 1. Because whatever's in those parentheses after the f is what we're going to put into the function. Now we're used to numbers. Numbers are nice because I take the number, plug it in, simplify. It doesn't have to be a number. It can be whatever's in that parentheses. Because when I plug into this here, this square.
May I have your attention, please? Anyone who has not gone and had their drug test done yet today needs to go to up there at this time. Anyone who has not had their drug test, they need to go up there at this time. Thank you.
Because whatever we put in this square is also going to go in this one. So what we did for this one here is we plugged in x plus 2 here. We had f of x plus 2, which means we also plug x plus 2 in here. Does that make sense? Here? Okay, here. Yes. So we're plugging x plus 2 into the function. Because what is our function? 2x plus 1. So here, I don't have f of x. I have f of x plus 2. So what we're going to do is we're going to plug this x plus 2 in for this x. So I still have the 2 from the function. But this isn't x anymore. It is now our x plus 2. So we took this part here and plugged x plus 2 in for x, which gave us our 2. We're not just switching from f to 2. We're saying that f plus 2, f of this x plus 2, when I plug that into the function, instead of having 2x, we have 2 times x plus 2. Yeah, so we just took this and plugged the x plus 2 in for. Does that make more sense? Okay. Any other questions on our left or right? Because this is a little different. Up, down's nice. We just add that value of k, replace f of x with what it's equal to. Here we're having to actually plug something back into the function. All right, we're going to look at more of these. We're going to do more of these, this up, down, left, right. So we look at the next one here. Let f of x equal 4x minus 9. Write a function, g, whose graph is a translation 5 units up of the graph of f. So up and down, our vertical translation is f of x plus k, where k is the amount that we're moving the function up or down. So for this here, our k value would indeed be 5. Now, would it be positive 5 or negative 5? Positive, we're going up. The value of k is indeed positive 5, so we would say that we have f of x plus 5. Now this here, this notation seems a little redundant, but it's helping us get the problem set up so we know how we're going to apply that transformation, where we're going to plug the information in to get our new function. So our vertical translation, the up-down, is going to be added to the function. Now at this point here, we need to plug the function itself in. Our f of x, we need to evaluate it. We'll plug that part in. So f of x, do we still just have f of x? So what we're really doing is we're plugging in x in place of x. So here we have our 4, and I replaced x with x, which just gives us 4x. We really didn't change anything. We just replaced x with itself. Minus 9 plus 5. So what we did is we replaced f of x with what it's equal to. We didn't change anything because it's still just f of x. So we get back with what we started. 4x plus 9, or 4x minus 9. Then we have our plus 5 for that transformation. Now, is there anything in front of our parentheses for the 4x minus 9? There's not a number in front of that first parentheses that we'd have to multiply through or distribute through. Since there's no number in front of it, we can remove those parentheses. Make that a little bit nicer. Because if there had been a number or a sign in front of that parentheses, we'd have to distribute it through. We'd have to multiply it through before we can remove the parentheses. And last but not least, we need to simplify. We need to combine like terms. And our like terms here would be our 9 and 5. Negative 9 plus 5 is negative 4. Telling us our new function is 4x minus 4. Questions on this here? Again, I'm rewriting f of x just so we can see it, so we're not having to go up and down, scrolling up and down a lot. We're ready for the next part, our left and right. So we want to write a function h whose graph is a translation 1 unit to the right of f. Again, h of x is just another way that we can name the function. Now our horizontal, our left-right, in the general form we call it f of x minus h, where h is the amount that we move to the left or to the right, our movement left or right. Now that value of h is 1 unit to the right. So the value of h is going to be positive 1. Because even when we were talking about them as movement left or right, if it's moved to the right, the value of h is going to be positive 1, but it's going to look negative, just based off how the setup is. X minus 1 is 1 unit to the right. Value of h is still 1, it just looks negative. Same thing with moving to the left. X plus 1. It looks positive, but the actual value of h is negative. The negative kind of throws that up. Here, we plug in that right movement. That value of h is 1, positive 1. But after we plug it in, we get x minus 1. Again, it's that looking the opposite direction. Questions on how we found h or how we plugged this in? Okay. Now we can apply this to our function f of x. Well, we don't have f of x anymore. Because when we had f of x, it told us that it equaled 4x minus 9, yes? In the function notation here, we've replaced this x here with what? X minus 1, yes? Which means this x here is also going to have to be replaced with x minus 1. Because what we're saying now is, I don't want to look, I'm plugging in for x minus 1. Which means the x over here, I'm going to have to plug into it, x minus 1. So the 4 is still there, but instead of x, we have x minus 1 minus 9. Questions on this here? Questions on anything we've done so? Questions on anything we've done so far? Questions on how we got to 4 times x minus 1 minus 9? Here we can distribute the 4. Our 4 times x is 4x. 4 times negative 1 is negative 4. And then we still have our minus 9. At this point here, we can combine like terms. We still have our 4x. But our negative 4 minus 9 is negative 13. So our new function, our function that was moved 1 unit to the right, is 4x minus 13. $11.18. So 1 unit to the right for how we got here, because 1 unit to the right, we're saying that this value of h is indeed positive 1, because right is going to be positive 1. So we plug that positive 1 in, which does give us x minus 1. Does that make sense? Yeah. This symbol here. So this here is just based, the negative or the minus inside is not based off the left or right. That's just the general form, x minus h. And we plug h in, the left or right movement. So if it's right 1, h, in our case, is positive 1. In the last one, we moved it 2 units to the left. So here, h value is negative 2 because it's left 2. But when we plug it in for left 2, we have x minus negative 2, which is positive 2. And that minus h is why, especially when we're describing the transformation, it's that opposite of what it looks like. because here left, we have that minus -2. That negative and negative made the positive. On this last one, we had right 1. H is positive 1. But in the function notation, when we write it, we have that x minus 1. It makes it look like it's going the other direction. Any other questions on this here? All right, we're going to look at another one with this here. F of x equals 3x is a translation of 5 units up. Again, our up, down. So we'll call this g of x. F of x plus k, where k is our movement up or down. Because here, this notation helps us be able to apply these transformations. And 5 up tells us the value of k. So up 5, 5 is our value of k. Now, would it be positive or negative? Positive, because we're going up. So we replace k with positive 5. Questions on this so far? Now we need to plug our function back in. We need to get our f of x. Inside the parentheses, still x, yes? So f of x is still just 3x. We didn't do anything inside these parentheses here, so we don't have to apply or change anything with the original function. So g of x equals, so we replace f of x with what it's equal to, 3x plus 5. Is there anything in front of our parentheses here? No. So we can just drop our parentheses. Telling us that g of x is equal to 3x plus 5. Are there any like terms? That's it. Questions on this here? We're going to do one last one for today. There we go. That's what we're looking at today. F of x equals the absolute value of x minus 3. And we want to translate this 4 units to the right. Now we're going to call it g of x, because really what we name it doesn't really matter. I just need a way to specify or signify that it's not the same function as f of x. Translation left or right, horizontal translation. The general form, again, we're using this just so we can figure out how to plug in, make it easier to plug in, simpler to plug in our values. F of x minus h, where h is the value of what we're moving to the left or right. Now for us here, h is indeed 4. Is it going to be positive 4 or negative 4? Are we moving left or right? Right. Right is a positive amount. Now it will, again, this is a left and right. No, again, that's why I keep checking in. Left and right can be very confusing with this here. Because right is positive, yes? And we keep, again, opposite of what we think with left and right, yes? So let's see here. When I plug it in for h, when we plug it in for its value h, we plug that positive 4 in, yes? Does it still look positive? No, that's the opposite of what we think. The value of h is still positive 4, it's still right 4. But when we have it in that function and in this notation, it looks negative. Are we starting to see that there? It's not so much that the value of h is the opposite of what we think. When we have it in the function, it looks the opposite. Okay? Because even if we refer back to the stuff we did yesterday, with inside the parentheses of being x minus 3, well, the value of h is still positive 3. It just looks negative. X plus 3, it's still negative 3 for left. It just looks positive. All right. Questions? Now, the last thing we need to do is put this into our function. We have now f of x minus 4. We don't have f of x anymore. We replaced the x in f of x with x minus 4, yes? So when we plug this into the function, we're going to replace every x on the other side of that equal sign with what? X minus 4. So we'll have the absolute value bar. Inside, we now have x minus 4 minus 3. We replace that x with x minus 3. Questions? Since there's nothing in front of this parentheses, we can just drop the parentheses. And we have the absolute value of x minus 4 minus 3. Questions on this here? That's it.